right, everyone, this is it. This is the last one. We made it. This is the last topic I need to cover in Stats 202 so that students in the class can do the exam. So this is going to be the last one. This is going to be on making a linear regression equation based on some data that you're given. And so, typically when you do it now, you do a lot of this in Excel, but we're going to do it by hand just to see the mechanics of how it works. So you'll see down here, what I did was I took the liberty of writing each of the equations we're going to end up using. In Stat 202, the questions always follow this same sort of format. We have a table of numbers with a couple variables, one being the independent variable and one being the dependent variable. And in this case, I'm going to outright say this is going to be your x and this is going to be your y, because hours studying is sort of your independent variable. It's the thing you could do something about, and then the grade on the final exam is obviously going to depend on your hours studying, not vice versa. I think in the answer key, for those of you taking Stats 202 or 260 or Stat 100 from SAS Polytech, they mix them up, but this is the way it should be. Now, they're always going to follow this same sort of format. Is there a significant correlation between the two variables? It wants you to compute R. Determine the linear regression equation for the data. So for this one, you're going to figure out y hat equals b naught plus b1 x. So what you're going to do is this y hat will be your predicted grade in the final exam. X is going to be some amount of hours studying that you put into it. And b1 and b2 are decided by these formulas. So now each of these individual expressions, one thing that's going to help us in figuring this out. Now this isn't a hypothesis test, so we're doing things a little different. We're jumping right into it. One thing that's going to be different here is that you're going to need some extra tables to help you compute things. So one thing you're going to have to add in is x squared, because if you'll notice, this particular expression requires you to have x squared values, and this expression here needs you to have the sum of y squared values. So we're going to need to add those in and compute those for each of the numbers here. So when you're on an exam, you're looking at this stuff, this is something you should figure out. You need to add in your x squared values to the side of the table you're given and y squared values on the other side beside your y squared. Now there's another one we're going to need to figure out, but for now we're going to go this way. The first thing you should do, is figure out each of these values. So 8.5 squared, I get 72.25. And I'm going to go through this whole process because I want you to see the work involved, what you need to do. 85 point, you know what might be easiest, because we're going to have to sum this eventually, is why don't we go through and we sum the hours studying first, then sum the grade on our exam, and then we go back through and we do the same thing for x squared. It'll be a little bit easier that way. So let's go for it. We're going to do the same thing with the calculator. We're going to enter it into the memory like we've been doing in the past, and we're going to use this sum of x button. So 8.5 into the memory, 9.25 into the memory, 7.5 into the memory, 7.5 to the memory, 8.25 into the memory, 9.5 to the memory, 9.25 into the memory, 7 into the memory, 7.25 to memory, and 8 into memory. How many is that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Well, these have the right number of them. So now the sum of x is going to be equal to, you just press second function, you hit that sum of x button, and I get 82. And you know what actually is neat? I just noticed this. I have no idea why. This is the first time I've ever seen this. They actually have the sum of x squared button right here. So this thing right here, I don't think we even really need to do this column. You'd get extra marks if you did it, but you probably don't need to. We'll save this column. We're going to do the same thing over here, but we'll save this column for x, y. Okay, you're going to need to multiply these together to get a number here. But sum of x, and then just hit second function and this sum of x squared button, and it's going to give you the sum of x squared, which you're going to need. You're going to need it for that. So as sum of x squared, this is 679.72 or 75 rather. I hope that's right. I hope so. I'll double check after, and if anything's incorrect, I'll I'll send a follow-up note or put something in the description. Now what we got to do is we got to enter all the grades on the final exam, figure out the sum of y with that button there. I know it says x there, but once you enter all the data in y, it's going to be the same thing. And then we need the sum of x, sum of y squared. Pardon me. So 87, 91, 80, 79, 85, 96, 90, 70, 73, 82. All right, now second function, sum of x, that's 833, and sum of y squared, 69985. Okay, now again, the important part is the process. I might have made a mistake on these numbers. You can double check for me. I apologize if I did. The important part is that you're following my process, and I'll put out any corrections if these happen to be incorrect. Now, xy, what we have to do is we have to sum them together, or multiply them. So 8.5 times 87 is going to give me 739.5. 91 times 9.25 is going to give me 841.75. 80 times 7.5 is going to give me 600. I'm in this column, and then we have 79 times 7.5 is going to give me 592.5. 79 times 7.5. I already did that one. 85 times 8.25 is going to give me, maybe I should just extend these out a little bit because I'm having a hard time keeping everything straight here. So I get 701.25. So this stuff is here, this one's here, and I'm sorry about this lopsidedness, everybody. 96 times 9.5, so that's 912. 90 times 9.25, we have 832.5. 70 times 7, 490. 73 times 7.25, 529.25, and then lastly 82 times 8 is going to give me 656. Okay, we're going to need sum of xy, by the way. This is why I'm doing this. Okay, because again, there's an expression down here. Where is it? Sum of xy. I need to put there. By the way, I should also mention that n is equal to 10 because we're going to use n as well. N's the number of data points. So let's start entering these into the data. 656, I would put into the data. 529.25. I'm just going backwards just because I started at 656. 490. 832.5. 912. 701.25. 592.5. 600. 841.75 and 739.5. 10. Now we just sum them all together because we need the sum of all of these numbers. So sum them all together, I get 6894.75. Now I want to point out that these numbers can be hard to compute, but the reason I wrote all these out all at once is I want to point out a pattern that you can see to make your computations just a little bit easier. So to save yourself a bit of time, what you need to do is save some numbers that are the same. So B1 and B2 actually have the same denominator. So I'm going to outline it. So you only really need to compute it once. So this will save you a little bit of time. I'll call this 1, and then I'll just put 1 over here as n times the sum of x squared minus sum of x all squared. And then we also have, and I'll get a different pen to do this, I'll get my blue pen out, we also happen to have this expression, oh, actually, you know what? 1 happens quite a bit. 1's actually down here as well. Right? It's the exact same thing. 1 is down here. So 1 is super important. 2 is this one. This one appears twice. This one, it appears up here as well. So this is 2. 2 is equal to n times the sum of x, y, which we just figured out up here, minus sum of x times the sum of y. Okay? Then we have the 2 leftovers. We have this one here and this one here. So I'll just highlight one of them in purple and one of them will be in black. So this will be 3. So I'll call this 2, 2. So 3 is going to be right here. This is going to be the sum of y times the sum of x squared minus the sum of x times the sum of xy. So really, this is just making your life a bit easier for you. Oh, and then the last one is down here, which is 4. This is n times sum of y squared minus the sum of y all squared. So then when I can actually rewrite all these equations as something a little bit easier. B naught is just equal to 3 divided by 1. B1 is equal to 2 divided by 1. And then R, let's make like a little box over here to circle, to piece things off. R just happens to be equal to 2 divided by, and now just be careful, remember that you include that square root term down here, the square root of 1 times the square, or times 4. Okay, I'm just going to rip this page off because we're just going to figure all these out. And really, this is the regression equation, but we're all going to figure it all at the same time. Every one of my regression questions that I'm going to give to any class that I teach are going to have this same format. We're going to need to figure out if there's a correlation between 2 variables and to what degree, or what is that correlation, and then also figure out the regression equation. So, okay, so the first thing we need to figure out, I'll just maybe fold this so you can see this a little bit better. First thing we need to figure out, 1, we have n times the sum of x squared minus the sum of x, and all of that has to be squared, and that whole expression squared. So let's figure out the numbers. N is 10. The sum of x squared is right here, 679.75, minus the sum of x is 82, all squared. Get my calculator out. We have 679.75 times 10 minus 82 squared. So I get 73.5 for 1. Flip this over. Got to figure out 2. So 2. This is going to be 10 because n, or sorry, let me write out the formula again, sorry, just so we all remember. N times the sum of xy minus sum of x times the sum of y. So n is 10. Stuff's up there. 10, and then sum of xy is 6894.675. 6894.75 minus the sum of x, which is 82, times the sum of y, which is 833. Okay, so when I write this out, this is 68947.5 minus 82 times 833 68306, which is going to give me 68947.5 minus 68306 gives me 641.5. I'm going to go up top here to number 3. If you remember what number 3 was, this was the sum of y times the sum of x squared minus the sum of x times the sum of xy. We take our values from here. So I'm just going to give myself a bit more space. Sum of y is 833. Sum of x squared is 679.75 minus the sum of x, which is 82, times the sum of xy, which is 6894.75. Okay, figure these each out individually just to make my computations a little easier. Times 679.75. Less room for error if I write every step out. 566,231.75 minus 82 times 6894.75 is going to give me 565,369.5. So let's just figure this out. 566,231.75 minus 565,369.5 is equal to 862.25. Four is equal to n times the sum of y squared minus the sum of y all squared. Okay, plug the numbers in. N is 10. We have the sum of y squared, which is 69985, minus the sum of y, which is 833, all squared. 699,850 is what I get there, minus 833 squared, which is 889, pardon. So 699,850 minus 693,889. It's going to give me 5961. Looks about right. Okay, now we're just going to use the little formula I drew up to write everything out. So the first thing we had to figure out, 1, was r, and r was equal to 2, which is 641.5 over, right? So, or you know what, why don't I write out the formula again, is 2 over the square root of 1 times 4. So 2 was 641.5 all over the square root of 1, which is 73.5, times 4, which is 5961. So just make sure you do that square root at the bottom there. So this is 73.5 times 5961 equals square root. So this is 641.5 divided by 661.9. 641.5 divided by 661.9. 0.97 approximately. So this is yes, there. So remember the question was, is there a significant correlation between the two variables? Well, remember from the from your textbook or from your manual, whichever you're reading, r ranges between -1 and +1, with +1 or -1 being a significant correlation. If it's positive, it's a positive correlation. If it's negative, it's a negative correlation. And 0, closer to 0, being a less significant correlation. But yes, there, because it's 9.96, that's really, really close to 1. So we say, yes, there is a significant correlation between time studied, and exam grade. Exam grade? Yeah. And final exam grade, in fact. Okay. Number 2, we want to draw that regression equation. Y hat equals B naught plus B1 x. Okay, so B naught is what we have to figure out. B naught and B1. So B naught, if we look here, is 3 divided by 1. Pretty easy. 3 is 862.25 and 1 is 73.5. So we have 862.25 divided by 73.5. We're going to get here 11.73. 2 decimal places should be fine. B1, we have 2 over 1. This is going to give us, where's 2? 2 is 641.5. So 641.5 divided by, what's on the bottom here? 1 is 73.5. So this is divided by 73.5. So I get 8.73. So what we get is the linear regression equation y hat is equal to 11.73 plus 8.73 x. All right, so now we got to answer the last couple questions, and this is really just making use of the equation. So 3, we want to determine the grade of a student who studied for 7 hours and 45 minutes. So be careful here. 7 hours and 45 minutes. This is not 7.45. This is 7.75, because remember, this is 0.75 of an hour. Okay, because you all have to make sure you have the same units. So 7.75 is this number. What we're going to do is we're going to plug that into x, because remember, x is the hours you studied, which I put right here, and y is the grade that you got in the final exam. So what we're going to do is we're going to say, well, y hat, what's this equal to? It's 11.73 plus 8.73 times x, which is 7.75. Let's figure this out. 7.75 times 8.73 plus 11.73. So the predicted grade, if you study for 7 and I guess 3/4 of an hour, is 79%. Okay? And then we'll just do 4 over here. It's not much harder. In this case, though, we want to say, if a student received 75 minutes, or 75%, how long did they study? So remember the formula, 11.73 plus 8.73 times x. Well, if x is where we plug in the amount of time you studied for, y is where you have to plug in your percentage. So we're saying 75 is equal to 11.73 plus 8.73x. So we have to do a little bit of algebra here. Subtract off 11.73, subtract off 11.73. So we have 75 minus 11.73. We get 63.27 is equal to 8.73x. So then we just divide by 8.73, divide by 8.73. What we get is x equals 7.25. So, let's just write in words. You need to study around 7 hours, 15 minutes to get 75%. Well, that's it. That's everything we need to be able to do assignment 5 and just the rest of the course and study for that final exam in Stat 202. Those of you who aren't in the class, I hope you enjoyed learning a little bit more about how to do linear regressions and hypothesis tests and even the stuff before. Yeah, so thanks very much for listening. Take care.